do 5.5-44 now, putting it all together. Find the solution to the problem below by graphing and also by solving an equation. This will be the equal values method. The solutions using both methods should match, so be sure to review your work carefully if the results disagree. Imagine that your school planted 2 trees when it first opened. One tree, a ficus, was 6 feet tall when it was planted and has grown 1.5 feet per year. The other tree, an oak, was grown from an acorn on the ground and has grown 2 feet per year. When will the trees be the same height? And how tall will the trees be when they are the same height? Okay, so the first thing that we need to do is write the equations for these trees. And we're going to write them in the slope-intercept form, which is y equals mx plus b. Okay, so the ficus is going to be, using the information they gave us, let's see, 6 feet tall when it was planted. So that will be our b, or where we started. And the growth each year is 1.5 feet per year. So we'll put the growth in front of the x, 1.5 times x. And then we just have to put y equals there. Okay, and now the oak. The oak is kind of interesting because it was planted as a seed, so it had no starting growth. That is 0. So we don't typically add on plus 0, but we'll leave that part blank. But the growth was 2 feet per year, so we have 2x. Okay, so now we have the 2 equations, and we need to find out when. So x is going to be the years. And y, of course, is the total feet in growth, or the height in feet. Okay, so we need to find out when the height of the 2 trees is going to be the same, or when y is going to equal y. So we're just going to assume that y does equal y. And if we know that this y is equal to this y, and this is equal to this, and this is equal to this, then we know that this has to be equal to this, because these 2 y's are equal to each other. So let's go ahead and rewrite the equation to 1.5x plus 6 is equal to 2x. And you can see now that we only have one variable, an x. So let's put these x's together, and we'll do that by zeroing out the x on this side. And we have to subtract it from this side too. So here it's zeroed out, so there's only 6 left on this side. And here it's 2 minus 1.5, so it's only 0.5x. And now we need to get the x isolated, so we need to remove that coefficient. And because it's multiplying x, we're going to undo that relationship by dividing by the same amount. And of course, we have to do that on the same other side too. 0.5 over 0.5 is 1. 1 times x is just x. And then 6 divided by 0.5, this will go into 6 12 times. Okay, so in 12 years, they should be the same height. But what is that height? Now we are going to find out what the height is. And I'm looking at these 2 equations, and the easiest one for us to calculate once we put in a value for x is going to be this one. So I'm going to use that equation, y equals 2x, and I'm just going to replace the x with our value right here, which is 12. So y is equal to 24. Okay, so when these trees are the same height, which is going to be 24 feet, it will be 12 years from now. So in 12 years, both trees will be 24 feet tall. Okay, and we found that out algebraically. So now they would like us to graph, and I actually already have the graph created, so I'm just going to show you. So if we graph the ficus, it looks like this. So we started out at 6 feet, and then we grew by 1.5, or 3 over 2 is the fractional way of doing it. So for every 2 feet, we went up 3. And then here's the oak, which started at 0, and it's grown 2 feet every year. So notice the scale over here for each square is 2. And over here, the square, each square is worth 1. But eventually they do meet, and they meet at 12 years, and they are 24 feet tall. So that's our conclusions, or our numbers that we found algebraically are also found in our graph.